Hello everyone, welcome back to my YouTube channel, General Technology Knowledge. Today I would like to show and share about how to use function that we call library FC105 scaling analog for use to connect with the generator, example phase A, B, C voltage, speed sensor number 1, number 2 and number 3, frequency, current, something. So we can use the function FC105 for scale the analog. Okay, and in this section I will use PLC S7-200 CPU 314C 2PN/DP and connect with the external module analog SM311 7KF02 0AB0. Okay, and I will use two softwares for testing and simulation. The first one is SIMATIC Manager version 5.6 and the second one is WinCC Flexible 2008 page 4. Okay, so let's go to our software to create the program. But before go to create the program for function block, or we call library FC105, I would like to explain the concept a little bit. Okay, so for generator, for example, we have the voltage, measure the speed sensor, right? Example, we have 3 positions, so we can install the sensor for 3 position. Okay, and the sensor will generate the current 4 to 20 milliamp to the PLC S7-200. Okay, and also we must measure the frequency, yes, and current also. Okay, so this is just example or concept of generator. And for measure this point, we must create the program for convert from the analog to show the raw or the actual value, example the RPM or show the volt. Okay, so let's go to our software to create the new project and use the FC105 to scaling. Okay, so let's go. Okay, so first we need to create the new project, and before create the new project we need to create the new folder, example generator. Okay, and the first one we need to open the SIMATIC Manager. Okay, okay, and then create the new project, so file, new project, or we can click here, yes, and we can write generator and browse to find the folder that we already created on desktop called generator folder, and then click OK and OK. Okay, and the next step we need to create the hardware configuration, so need to create the object. So I will use SIMATIC 300 station and then go to hardware configuration. Yes, so let's go to SIMATIC 300 and then go to add the rack. Yes, go to the rack 300 and then drag and drop the rail to the project. Okay, and then we will got the rack of PLC S7-200 11 slot. Yes, and then so we need to create the power supply for this rack, yeah, to supply the voltage to the CPU and I/O modules. And then we need to create the CPU, yeah, insert the CPU, and the CPU I will use 314C 2PN/DP, yes, and version 3.3, so we can drag and drop to the rack. Okay, and this one is the IP address, default IP address of the CPU. So 192.168.0.1, yes, and then click OK. And we will got the I/O for the default I/O, yes, module that built in on the CPU. Okay, and then we need to create one more for external analog input module, right, to the rack. So go to SM300 and then go to AI, it means that analog input, and find the serial number to match with the hardware module. So right now I will use 317KF020AB0. It related to the module, hardware module, yes, here. And then drag and drop to the rack, okay, here. And the next step is very important for this module because we need to select the hardware to be the same as the software. Otherwise, when we download to the CPU, it will show the fault, yes. Example, right now I will download, yes, but no need to adjust anything or select to change anything. So let me show. It will error when we download to the module. Okay. So right now, before go to download, first we need to know about the IP address of PLC, right? In the previous step, I already showed its IP address of PLC is 192.168.0.1. Okay. Then we need to know the IP address of PC. It means that our computer. So we need to put the manual for Ethernet module because right now I connected the LAN cable from my PC to the PLC. Okay. So let's go to put the manual mode by right click here, open network and sharing center, go to local area connection, and then go to property and go to the internal protocol version 4, yeah, IP4, and then click property, yes. So in this step, if everyone not select example here, actually it like this. So when we open first time, yeah, it will automatic for IP address, right? So we need to put the IP address to the same as the rank of the PLC, right? So it should be 192.168.0. Something, but not yet, not .1. Okay, so example not dot 1 I will set dot 253, yeah, and for subnetmask it will be 255.255.255.0 because it class C, right? And then click OK, OK again, and then click close. So IP address of PC is 192.168.0.253, okay. And we can ping, yeah, by press Windows plus R, yes, and write the CMD. So we can ping 192.168.0.1 because it is the PLC IP address, right? Here. And then press enter, yes. So it's so like this, it means that we can communication between our PC to the PLC, okay. And then if everyone would like to ping every time, we can use the .t, yes, it will ping every time, yes. So right now let me save the project and then go to download, because we already connect the LAN cable to the PLC, and then we can connect also, okay. So to download the hardware configuration to the CPU, let's go to download, click download one, and then click the select all, and then click OK, and wait a moment for detecting. It will automatically detect the CPU because right now we already connected the LAN cable from our PC to the PLC, and we also can ping, yes, here. So wait a moment for automatically detect with the PLC, yes. Okay, so right now it detect one CPU, yes. Here is the IP address, and here is the module type, yes, station name, yes, and module name, okay. So we can click OK to download, and it will show false because right now I select the hardware, yes, the hardware of the external module. Right now for channel number 1 I select to C, it means that for Y current. Channel number 2 also to C, but channel number 5 and number 6 I select to A, it means that PT100 or thermocouple, yes, and channel number 6 also. But the actual that we download is select to default, right? Because right now I want to test the fault signal to everyone. Otherwise, if everyone have fault, the system fault on the module, everyone can trouble it, okay. So if I click OK and then start the CPU, the CPU is full right now, yes, because we not yet select the input, yes, input type, so it will fall. So right now we need to select the input to follow our selection on hardware. So channel number 1 and number 2 we will select to current, yes, for Y, okay. So let's go here and then select input, and channel, this channel I will select to current input for Y, yes, for to 20 milliamp, and for channel number 2, right, it will for Y current also, so I will select to current for Y, but channel number 4 and number 6, sorry, number 5 and number 6, I will select to PT100 and thermocouple, right? So right now for this channel I connect PT100, and for this channel I connect thermocouple. So both of channel we can select to A. Okay, so here I will select to thermocouple, yes. Okay, standard PT100, and this one I will connect to TC type K, yes. So that's correct, and then save the project again, and this one also it full. So right now I will use current for 220 milliamp, current for 220 milliamp, current for 220 milliamp, and one more current for 220 milliamp also. Okay, and for this one I will select standard, okay, PT100, yes, because right now I already connected the cable to this channel also for PT100. Okay, so let's click OK and then save project again, and then download again by press button download, and then press OK. So right now we no need to wait because it already detect to the PLC, and then click OK and we stop again, and then click yes to run the CPU, yes. So right now we already insert or configure the hardware configuration. So for the next step we need to use the FC105 to create the scaling, right? For show the voltage, phase A, B, C, sensor, number 1, number 2, and number 3, frequency and current of generator. Okay, so let's go. Okay, I will minimize this one and close this one. So first go to SIMATIC and then go to blocks. Okay, so we can go to the OB1, double click to OB1, and then we can comment on the network, example voltage phase A of generator, yes, and we will use the FC105, right, from the library. So go to library and then go to standard library, and then go to TI Advanced Converting Blocks. Okay, and then scroll to find the FC105 scale convert, and then drag and drop to the network 1, yes, we will got like this. Okay, so we can use the first address because we use the voltage phase A, right? So we need to go to hardware. Okay, this one. It will start from PID 800, right? So example PID 800. Okay, and we can also edit the symbol, yes, and the data type is integer, example voltage, example phase A, voltage. Okay, like this, And for voltage, I will set the high from 0 to 400 volt. Yes, so this one 0 to 100 voltage. And for this one, we can use another address that we want, example M0.0. And for this one, we can use another address that we want. If everyone not clear, we can press here and then press F1. So we can assign the address that we want like this. Example MW 0. Okay. And this one example MD 100. Yes. And we can save and then we can download and then we can online to check. So right now it show around 99 volts because I already connect the standard source for simulation, connect the milliamp to the channel. If I adjust, let's see here, it will up 20 milliamp, it will show around 399, yes, 399 volts. Okay. So we need to use the phase B, the same as this one. So we can insert the new network, drag and drop here. Okay. And then it will start from PID 802, right? Because PID 800 we already use on phase A. Okay. So this one we can copy and then paste. Change this one to B. Okay. And for this one 400.0 0.0 M0.1. Example MW 4 MD 104. Yes. Okay. And this one we can edit the symbol. Data type is integer, and for phase B, voltage phase B. Yes. Or we can command the same like this. Phase B voltage. Okay. Okay. And we can insert new network and we can copy this one. Yes. Paste. 804, right? And we can edit the symbol to be integer for data type and phase C voltage. Okay. And the scale is the same, but I will change this one to M0.2 MWH MD 100H, and this one I will copy this one to pass for phase C. Okay, and you can save and then download to the PLC and we can online to see. Okay, so right now let's see, because I connect the current to the same channel. Yes, because right now let's see here, the value is the same. Okay, so the continue to this step, we will use the PID 806 to show the current, right? So let me show. So we can insert, copy this one to here, and we can command current of generator. So I will use PID 806. So we can edit the symbol to be integer and then current of generator. Okay. For current the generator, I will change the scale from 0 to example 150 M. Yes. And this one I will change to M 0.3. And this one should be 12. 112. Okay, and the next step I will copy and then insert the new network for frequency, right? So frequency of generator, okay, frequency of generator. Then I will use the channel number 1 of this card. Yes, because this one we can use only 4 channels, right? Because it is the RTD. Okay, so I will start from PID 5.256. Yes. Okay, so PID 256, it is the frequency, right? So frequency integer also, frequency of generator. Okay, and for frequency I will use around 60 Hertz, because if we set only 50 Hertz, it will maximum, because it can increase over 50 Hertz. Right now I will set 60. Yes, and this one change to M 0.4. And for this one I will increase to 16, MW 16, MD 116. Okay, so for voltage and current and frequency of generator we already create. Okay, so we can save the project, and in the next step we will create the speed and temperature of building, right? So I will create the speed. Yes, for speed is 3 position. Yes, this one speed sensor number 1. Okay, so I will start from PID 258, the channel number 2 of this card, right? This one. Yes, So PID 256, okay, and we can edit integer also. So speed sensor number 1, okay, and for speed the generator right now around 3000, yes, and this one I will change to 0.5 M0.5, yes. This one I will change to MW20 MD 120, and for speed number 2 I can right click, copy, and then insert the new network and then paste, and we can copy and paste this one, change to speed number 2, and this one should be 260, yes. Edit the symbol, it is integer also, and I will command speed sensor number 2, okay, and the scaling is the same, 0 to 3000 rpm. This one I will change to M0.6, okay, and this one should be MW24 MD 124, and for speed number 3 we can copy from here and then insert the new network and then paste, copy this one, and then number 3, right, and I will use the PID 262, yes, okay, and we will command, yes, speed sensor number 3, scale is the same, but I change this one to M0.7, and this one 20H MW20H MD 120H, yes, and we can save, yes, and we have three more for temp bearing and temperature winding of generator also, okay, so I will insert new network, okay, so we can add more for temperature, but the temperature for bearing of generator and winding we no need to use this one. I mean that we no need to use FC105, yes, so this one we can command of bearing of earn bearing or heat bearing. So we need to convert from integer to double integer, right? So we can use the integer to double integer, yes, and then I will use this one, yes, yes. The last one of the internal module, yes. So it will PIW 808, right? And then we can comment, yes. Temperature of head bearing. Okay. And then for this one, I will use the temporary variables. Okay, I will create new for example temp1, or we can write var1 value1, yes. And the data type is double integer, right here. So dint. Okay, so this one should be var1. And I will convert from double integer to real, right? So di to real, yes, this one. So this one should be copy and then paste here. And then I will insert one more for temp. Example var2. And the data type is real, right? Here, double integer to real. So real. So var2. Okay. And then I will divide this one by 10. Because in the previous video, we already learned about how to connect the PT100 to the PLC S7-200 module. Yes. And then I will divide real. Yes. So I will divide this one by 10.0. And then I will show MD. Yes. 132, right? Because here we already used the 128, yes. Plus 4, yes. Okay, and then I will create one more network for earn bearing temperature. So we can copy, paste, copy, paste, copy, and paste. Because it's the same procedure, right? So this one I will use, yeah. This one is, that's all, right, for file channel. So for this temperature, I will start from the PIW 264, yes. Because here we just use 262. And then here I will use PIW 264, yes. And then we can use the integer and then comment temperature temperature earn bearing. Okay, and this one I need to convert from integer to double integer, right? So example var3, and the data type is double integer dint, yes. So var3, and I will copy var3 and paste here. And this one double integer to real, right? So var4, and the data type is real. Okay, so var4, copy Y4 and then divide by 10 also, and this one for show the actual, yes, then 36, right, 136. And the last one for the temperature of winding, it means that we can check also for the coil inside the generator, yes. So we can copy from here, temperature of winding coil, okay. So I can copy, Control C, Control V, Control C, Control V, yes. And then I will use the PID 268, right? Because it is the last one. Let's check here. PID 260, PID 262, PID 264, and then PID 266, right? Because 266 we cannot use it, use for 264 and 266, so this one should be PID 268, right? And we can remark integer also, this one temperature winding of coil, and convert also. So Wi-Fi, it is DINT, so Wi-Fi here, let me Control Z, Control Y, yes, Wi-Fi double integer, right? So Wi-Fi, and this one PID 268. Then I will copy Wi-Fi to here and insert one more for Wi-6. It is the real, right? So this one should be Wi-6. Copy Wi-6, paste here, divide by 10, and then the result is 140. Okay. So that's all for create the block of temperature and voltage and frequency, current, and also temperature of bearing and winding. Okay. So let's save our project and then download to the PLC, and we can online. Yes. So it show around 36, 25 something. Yes. Okay, so we need to show this one to the HMI, right? So we will create a new project of HMI also. So let's go to WinCC Flexible here. Double click and then create a new project of WinCC Flexible. Okay, create an empty project and then choose the touch panel that match with our hardware. Yes. So right now I will use TP177B 6-inch color PN/DP. Yes. And the next step, we need to create the connection, right? So example connection 1, I will rename to HMI 1, and the driver communication is connected to SIMATIC S7-200 400, right? It many brand that we can use. Example GE Farnat, LG, Mitsubishi, Omron, yes. So right now I use the S7-300 400, yes. So click here, connection of generator HMI, yes. And don't forget choose the Ethernet, yes, because right now we will simulation by using the LAN cable. So here the IP address of our computer, right? So 192.168.0.253, okay, 192.168.0.253, okay. And here is the IP address of PLC module. So 192.168.0.1, yes, 192.168.0.1, yes, okay. And then we will create the screen, yes. So let's go to the symbol, okay, go to the motor to create the symbol, right? Okay, go to motor here, and I will use this one, yes. It's similar to be a generator right now here. Let's see. Okay, and we can use the text. Okay, go to the text file. Example generator of turbine, yes. Then we can increase the font. Okay, I will change the background of screen to be this color, and change this one to be 10. Okay, Tacoma 14, yes. Okay, like this. And then I will change the color to be this color. Okay, good. Adjust this one a little bit, yes, like this. Okay, to center. Actually we can resize, yes, this one also by using this one, yes. Okay, and then we need to show the voltage of phase A, B, C, right? So we need to create the text. Let's go to the text tab. So this one should be volt A, yes, volt phase A. It is the real, right? And what is the address? MD 100. So MD 100. Okay. Volt B. Okay, change this one to B. 104. Okay, automatically, and we can command. Actually, we can command here. Example, voltage phase A. Copies, paste, voltage phase B, volt C, it means that voltage phase C, yes, phase here. Okay, 100 H, 100, 104, 100 H, yes. Be careful if we put the address here incorrect, it also incorrect here, right? So the next step, we need to create the current, right? So MD 112, so current 112, current of generator. The next step is frequency. Okay, let's check the address. Frequency is MD116. Okay, the next step is speed sensor. MD112 120. So speed sensor, example speed 1, yes. Frequency, okay. Speed, position number 1, speed 2, speed position number 2. Okay, and how about speed 3? 128, right? So speed 3, can pay this one. Okay, and one more for temperature of heat bearing, right? So temp heat, what is the address? So MD 132, right? 132. Okay, so heat bearing, temperature, the next temperature of urn bearing, right? So we can copy and then paste here. Just change this one to urn bearing. And the last one is temp winding, right? So winding temp winding. Okay, temperature of winding. Okay, so that's all for creating the text. So we need to create the screen, right? So I will go to IO files, create the platform, and then copy and paste. Yes. So this one just output, and should be this format. Yes, or this format. And let's go to property, go to the text. I will change this one to 12, and then center, middle, and let's change the property to text color should be green. This one should be black. Yes, and also has the solid. Yes, example white. Yes, to be a cover. this one. Okay, so I will copy. Example, this one voltage phase A. So phase A. Okay, like this. So change to center and then change to middle. Okay, and then change color to be yellow. Yes. Okay, phase A here. Then we can arrange to be good looking. Yes, like this. Phase B, just change this one to phase B. And then phase C also, change this one. Drag and drop for copy. Okay, change this one to phase C. And for the unit, we need to create the wall, right? For unit way. Okay, or we can change to the white color. Clearly white color, yes. Okay, wall also. Okay, and then we can change this one to output also, and then wall A, right? Voltage phase A here. This one voltage phase B, and this one voltage phase C, right? Okay, and then we can save the project to generator. Okay, and then we can simulation, yes, to test. Wait a moment for running simulation, yes. Okay, so right now it shows around 200 and 199 volt. So if I adjust the milliamp, yes, let's see the voltage around 300 volts, yes, for phase A, B, and C. And then we can add more for current and frequency. So I can copy and paste here. Example, current we can put here. Okay, current. So we can put the tag for current, yes. And the unit is M. Okay. And one more for frequency. Okay, so we can copy this one for unit of frequency, yes. Control C, Control V. And for this one should be hertz, right? Okay. Current, and this one for frequency around like this. only one decimal, yes. So this one should be a frequency here. Okay, and we need to show the speed sensor position also. Okay, so let me copy all like this. So speed sensor 1, sensor 2, and sensor 3, because speed is very important, yeah, for generator. And this one should be RPM. Yes, RPM. Yes, RPM also. And this one, speed sensor 1, yes. So I will change to speed 1. This one change to speed 2. And this one change to speed 3. And we must change the format, yes, because for speed it 3000, right? Okay, so I change the format to be like this. Okay, good, like this. And we have the we have the temperature also, right? For heat bearing, earth bearing, and temperature of coil winding. Okay, so I will put here. I will use this format, yes. Example, I will put here for temp bearing, heat bearing, yes. So we can use the heat bearing, and the unit is degree Celsius, right? Okay. Degree Celsius. Okay, I will put here. And I will change to the yellow color, yes. So this one heat bearing, and this one for earth bearing, temperature, yes. Copy and paste, drag to here. Okay, and change this one to earth bearing, and the last one for temperature of winding, right? So I will put here for temperature winding. And then copy this one and paste here. Okay, something like this. And then we can save the project and then simulation, yes, to see the condition. Okay, like this. So right now the condition show like this. Yes. So I will increase the current. I mean that increase the milliamp to show to everyone. Yes. Example, I will create the volt. Yes. Okay, I will create the volt. Yes. Maximum around 400 volt. Yes. Decrease and increase here. Yes. And I will increase the temperature also. Let me hit the temperature. Okay, it will increase, right? Okay. So this is just instruction about how to use the library to convert from the raw value to the real value of analog input that I already show in this video. Okay. So if everyone have the project to be similar like this, everyone can use the PLC S7-200 to use. It's easy to create because we have the library. Yes, many library that built in inside the software. Okay. So thank you very much for watching my video. And if everyone have any question, please kindly drop comment under my video. I will reply soon. And I would like to request all of you to like, share, and subscribe my video also to get more notification and more new videos that I will create step by step. So in this time, I would like to say thank you very much again and see you next videos. Bye bye.